Okay, 4 on the worksheet is y equals x squared, so it looks like this, correct?
Yeah.
But it's rotating around the y-axis, so it's rotating this direction. When it's around the y-axis, we do everything in terms of y. All right? So my integral is 0 to 4. Y'all understand where that came from? And since y equals x squared, x is equal to y. And I don't have to do plus or minus because radical y is the radius. And remember, we're doing pi r squared on each of them. So this is going to be 0 to 4 of pi y dy. Which is y squared over 2 from 0 to 4. And this is times pi, which is 8 pi. Does that make sense to you?
Is that just the first part? Or
That's just 4.
do we have to subtract it or anything?
From what?
Oh, wait, the subtracting thing is only for...
But it's not around the axis. Because it's right minus left. Right is radical y, left is 0.
Yeah, okay. I was thinking the R1 minus R...
Oh, no. That's when it's a disk. That's when it's a washer. This is a disk. That was what I was going to find next. I was going to do a... Mine is just like this one.
I know, but so it's also going around the 100 that's because it's trying to get on the line.
Doesn't it become y to the 3 halves? I was looking for a harder one. All these are pi r squared. I like 11. Can we go to 11?
On page 3, there's 3 6s and 2 7s.
6 BCD.
Oh, it's AB. Oh, okay.
Yeah. A, B, C, D.
Yeah.
A, B, C, D. All right. Take a minute and read problem 11. Got it? You know what it looks like? It is a sideways parabola. And it says x equals 4. So I want to find this as it revolves around this line. All right? Does that make sense? So, I have x equals y squared. It's in terms of y. So what I need to know is what is my integral? My integral goes, because it's in terms of y, I'm looking at top and bottom, right? So my integral goes from here to here. All right? Does that make sense to you? You don't understand why it goes from there to there?
Why doesn't it go from the x-axis to the top? That would go over like...
Well, I can do that from the x-axis to the top and double it. Because remember, I've got, basically have another one of these over here. Right?
Why you just did the radius?
But the radius is this. This is the radius.
Okay, so it's spinning like this, like actually around the dotted line.
Around the dotted line. Okay. It's like a washer sitting on top of it.
And it's going horizontally instead of like this way.
Now, this is x equals 4. If x equals 4, what is y?
0.
If x equals 4, I didn't mean to use that though. No, x is 4. The other way, Luke, isn't it negative 2 to 2? Now, instead of doing negative 2 to 2, I'm going to do 2, 0 to 2. I like it better if I get 0 in an integral. You guys have figured it out that makes it way easier. Right? Yeah. Now, isn't it pi r squared? What is r? Is r from here to here? What?
Is this a washer?
Squared?
Why does it go from the 6
Because it's right minus left. Now, don't I need to take out this area? But if I go from 4, it just gives me this much. Yes, but that would mean it's spinning around the 4. Because see, it's going to be bigger because it's going to come clear over here. Now, so what do I subtract? What? 6 minus 4? Right minus left?
Why did we do these other ones like yesterday with 2 intervals?
With what?
With 2 different intervals.
I could have done this with 2. I could have. So, isn't this 2 pi 0 to 2 of 36 minus 12y squared plus y to the 4th minus 4 dy? Right? Which is 2 pi times 32y minus 4y cubed. What? At 36 minus 4. Plus y to the 5th over 5 from 0 to 2. I've got this one? Okay. If you insist, 2 pi, isn't this 64 minus 32 plus 32 fifths? Well, it was just 32 plus 32 fifths. 32 is 160 fifths.
The 2 pi times.
Yes, not plus, times. I was so worried about getting that number right that I lost my... $384 pi over 5.
Is it cubic units?
It is cubic units. No. The new bus? Where? What happened?
I heard Miss Hollingsworth say it was something with the tire.
No, that was her car. Her car broke in.